Hi, my name is Patrick, and this is a redux of a presentation I gave at Twin Cities Nerd Nite this week. I'm going to be talking about two of my favorite things, kissing and higher dimensional geometry. In particular, we're going to be talking about a thing called the kissing number, and you might be thinking, well, isn't that just the number of people I've kissed? Well, you got to think more non-monogamously than that. The kissing number is if I were round and everybody else in the universe were round and we were all the same size, how many of them could kiss me at the same time? In two dimensions, round things are disks, so the question there is how many of these blue disks can you fit touching the yellow disk at the same time without any of them overlapping and without picking any of them up off the page? And the answer is 6. You can fit 6. They fit around it perfectly with no wiggle room, and so the kissing number in 2 dimensions is 6. In 3 dimensions, the situation's a little stickier. In 1690, Isaac Newton said the answer is 12. Another mathematician at the same time said, well, yeah, you can fit 12, but there's so much wiggle room, I bet there's a way to fit 13. Nobody proved that Isaac Newton was the one who was right until 1954. Now, what if you had 4-dimensional balls or 5-dimensional balls? Okay, so what's a 4-dimensional ball? Well, we're going to tackle that question 2 ways. First, algebraically, and then pictorially. Algebraically, a 2-dimensional ball is all the points xy with x squared plus y squared less than or equal to the radius squared. And a 3-dimensional ball is all the points x squared plus y squared plus z squared is less than or equal to the radius squared. And in fact, we can even go back and define a 1-dimensional ball as all the points x squared less than or equal to the radius squared. So all the points from minus r to plus r on the number line. And because we're stuck on a line in 1 dimension, we can make one touch it on the left and one touch it on the right, and there's no wiggle room, there's nowhere else to put any. So the kissing number in 1 dimension is 2. Now, looking at these, it should be kind of straightforward how we're going to go up in dimensions. We're going to take one variable for each dimension, we're going to square them all, we're going to add them all together, and check to see if the answer is less than or equal to the radius squared. And if it is, then that's part of our ball. Now, pictorially, if you slice a 2-dimensional ball, each slice is a 1-dimensional ball, and those slices start out small, get big really fast, and start slowing down, start getting small really fast until you run out of things to slice. The same thing happens in 3 dimensions where the slices of a 3-dimensional ball are 2-dimensional balls. And in fact, this pattern continues so that the slices of any n-dimensional ball are just n-1-dimensional balls. The top picture here is 5 slices of a 4-dimensional ball, and you can see that each slice is a 3-dimensional ball. The picture below it is 5 slices of a 5-dimensional ball, and as you can see, each slice is a 4-dimensional ball. So now back to kissing numbers. We know the kissing number in 1 and 2 dimensions because there's configurations with no wiggle room. We know the kissing number in 8 dimensions and 24 dimensions because there's also configurations with no wiggle room. In 3 dimensions, we know the kissing number is 12 because we proved that 12 is possible and 13 isn't. In 4 dimensions, we know that for similar reasons that you can fit 24, and even though there's some wiggle room, there's not enough wiggle room for 25. In all the other dimensions, nobody knows the exact kissing number. So for example, in 5 dimensions, we know that 40 will fit and 45 won't fit, but maybe there's a way to fit 41, 42, 43, or even 44, nobody knows. Now, looking at this chart, the next non-monogamous question that should be on your mind is, what's it like to be kissed by 240 people in 8 dimensions? Well, the top picture here is a selfie of just that situation. The picture below it is the 4-dimensional case of 24 people kissing you and the 3-dimensional case of 12 people kissing you. Those aren't selfies, but third-party photographs.